Hello. Can you hear me? Yeah, I think you can. Good. Sorry for I'm not super adapted to the main theme because a lot of cats and usually have a lot of cats on the slide. Sorry for that. It's not today. I even have a cat T-shirt, but I left it at the hotel, so I am not prepared. Well, but fortunately, I'm prepared with content. Probably good content. So cats later. Build your own internet of continuously deliver things. So as you can predict, it will be about IoT and about delivering software, but not only. So what about me? I live in Krakow. I spent over a year in Kyiv before, but I'm from Poland. I work for Brainly now. Anyone recognize the company? Probably not, because you are too old. It's educational platform for students up to 16. So I suppose we have now one born after 2000 here, or do we? Okay, no. So we are old, and that's why you don't know. We set up 2 meetups. Ukraine QA when I spent in Kyiv, and I struggled with speaking Russian. I mean, still struggling because I don't speak Russian. And now it's QA in Krakow. So I'm like officially I'm test automation manager slash CI/CD lead, but I prefer to type it as QA lead just to simplify without like adding details. Cool. So let's start. Actually, who of you know what IoT is, or who of you can explain what is Internet of Things? You can raise your hand. Feel free. More or less, it can be less. So I will explain as well. But regarding how to deliver software and how to deliver good product, good IoT product, a lot of companies are still struggling. So as you see, not many of you even have an idea what IoT is. And if we talk about delivering Internet of Things software and devices, it's even less recognizable. So what Alan Key said, this guy from Xerox, so that company you probably recognize somehow. The best way is to invent it, and that's how we approach actually till now, because like the product slightly changed, but the approach must be invited. Okay, so that's Wikipedia definition. As we know, Wikipedia definition is always true. So that's why I explain you in my words. So IoT basically is exactly what we call internet, but for real devices. So if you have 2 physical devices, like bulb and I don't know, lock door, they can communicate between each other, they can exchange data, they can make some decisions, and they do it in an autonomous way. And of course, aggregating data, then makes then some logic inside, and so on. So as you can imagine, internet plus physical devices, that's Internet of Things. And I think that's much easier explanation. Now, I like that example of connecting hardware and services, which is like IoT devices, plus service, which is Twitter here. And of course, you should have mobile phone notifying you, hey, you are like fit enough. It depends on the country, yeah? But it can be fit enough. Good. So regarding data, why that speech and why I decided to talk about IoT, not software? It's just 2016 and 15. It's 6.4 billion devices, which is quite a lot. Next year there were 30% more, and then next year it was already another 30% more. And it's predicted that till 2025 it will be over 30 billion devices, which is quite a lot. I think the biggest installation I know is Arena in Amsterdam, so National Stadium, with 50,000 bulbs, and that's pretty huge installation if we talk about IoT, and it works autonomously. So you just let's call plug and play. Yeah, you don't need any wires. They are communicating between each other. The simplified infrastructure can be like that. Of course, we have a very simplified backend, whatever it is, like some data stored, some logic behind. But the most important is the hardware side, which is our device side, and the client side. And because Internet of Things is about new technology, is about comfortable usage, usually we use at first place, it's mobile first. So the assumption about IoT is that I give it to my grandma and she can use it. So that's assumption when you create IoT devices. And that's why it should be super simplified. It's smart home in that context, I think the most popular, but it can be, like previously in Ukraine, I worked for the company doing cameras for pets. So it's camera with laser for cats. So when I'm here, fortunately my cats can play with laser at home. And I can feed them, yeah, that's IoT. And I get notifications when the movement is detected. That's IoT. I don't know if it's useful, but probably it is because like I think this year, at the beginning of this year, one of the companies in US gets $100 million during investment round. So that's not small money. But that's a general approach. So you can connect wirelessly via Bluetooth, for example, or you can connect via internet. It depends how close you are to the device. Now, what is the challenging? Because it's mostly about delivering good quality. So if we talk about good product, the most important is to deliver it fast, because competition on the market is very, very big. And we talk about new technologies. So time to market and quality, because Internet of Things are called high or premium product, mostly because of the price. I think that's why. So we have some challenges, and it's like iceberg context, iceberg concept. So probably you know that. So we have software. You can do whatever. You can set up your infrastructure, for example, at home, and you can set up your mobile application, or additionally some web or desktop application. But below, you have the whole hardware with all the sensors, with electronics, with electric circuits, and it doesn't work. Just give me a second. Okay, it's working now. And you have firmware. Do you know the term firmware? It's software on hardware. That's called firmware. So if we have ARM processor and we type something there, we usually write firmware. So firmware basically is software on hardware. Now, because of technology and because of mostly still quite niche, mostly startups are involved into creating Internet of Things, because they are like, we need to try concept, we need to check if it's on the market, and then probably, fortunately or unfortunately, if the company is successful, then it's acquired by a big player. Like Philips did it with many companies creating smart bulbs, like Amsterdam case. So what is the problem? Well, at first, lack of time, no proper approach, because we have no time to introduce. No documentation, but it's, I think, common not only for high-tech companies. Not enough testers, because we invest in development. We want to deliver fast, and we take care about creating new functionalities mostly. Something I call event-driven development. So we create functionality to show off on the event, to show off CES. I think that's the biggest. And very chaotic environment. Constantly changing environments depend on the customer needs, depend on the investors' requests. That's very common. And of course, we have the previous point, so events, and you want to target the specific events. So that's the usual pain. And I work for 4th startup now, different product, slightly different area, but the pains are still the same. So at least it's fucked up but stable. Now, let's imagine a simple scenario. You have 2 bulbs, and you have switch. So what does matter? You have 2 bulbs. You take the switch, of course, wireless. You want to connect them. And then you want to, at first, use your mobile phone to turn it off, and then use your switch to turn it off. Quite simple, right? At least as a concept. At least what my grandma hopefully can do. So use smartphone, click once, and then using switch, just turn it off. Now, the scenario to check if that's working, because if we talk about continuously delivered things, we put much more effort on quality of the product than probably in different areas. I can give you a simple example. If something is wrong with web application, we can make rollback. Yeah, that's quite quick. If there is something wrong with mobile app, we can put new version, and then we need to wait until review and so on. But still, it's quite easy. If we have desktop application, sometimes we need to force user to uninstall and install again, but still, yeah, it's possible. Now imagine if you want to put new firmware on the device, and this firmware doesn't work. So what is the result? Brick, yeah, that's called brick. So we cannot do anything. And the only solution to make new firmware again is to send it back to the company and get the new device. And me as a customer, I'm not really satisfied because of that. Yeah, so I need to give them device back and then waiting for the new delivery. That's why we put so much effort on quality. So, for example, at my first company, we had like 60 people, including 14 testers. That's a big ratio. And imagine it's not like another 45 are developers, because we have sales, we have product as well, we have support. So that's huge. Of course, mostly it's automated, because we want to deliver fast. And as I remember, there were maybe one person just doing manual tests. Everyone else was involved in creating pipelines and creating, let's call it quick delivery, quick and efficient, and of course stable. Yeah, that's what we target. Now, how does it work? Well, we need to flash. Flash means put new firmware. Then we need to configure it, so build our infrastructure. Then execute scenario and probably close it, so do something else. Now, seems quite simple, yeah? We create environment, we turn off. We need to turn on first, and then we can turn off, and we can check. Now, well, it's not that simple. Now, why? At first, we need to somehow flash it. So, from the customer perspective, it's flashed in a wireless way, yeah. But if we want to have stable environment, we cannot do it, because if we want to check update, and it's bricked, then our environment is not stable, and our pipeline is blocked. We cannot provide new firmware. Okay, I have no idea what I'm doing, but it's working. No? Okay, let's leave it that way. Screen. This one, I don't know, it's not stable. Yeah, then how to trigger buttons, because usually we trigger it by hand, yeah? But we don't really want to employ new student just to click it by hand. I mean, in Poland, for some reason, we have a phrase that every good specialist can be exchanged by finite number of students. But it's not a good idea, yeah, to follow that practice. Then how to check if the bulb was really turned on or off. Now, we can check the state. Yeah, we have Bluetooth communication. We can capture all those packages in the air. But does it matter? Does it really mean it's turned on? No, we need to check the real behavior. And that's the main difference. We have real behavior, not only data. And then how to connect everything together and have that infrastructure really working. And of course, something else, because like challenges are always and always again. Now, when we talk about automation, all those items we need to take into consideration. Most of them you know, or at least few of them. Yeah, that's like REST, cloud, and so on. But then we have firmware, which must be checked. Then we have vision system, because that's the only way to check the real behavior. Yeah, we need to have camera for bulbs. For buttons, it would be some another like what it could be, like button with state 0, 1, yeah, to check, or some motors. And hardware, of course. Now, when we started, because like that's the story from the very beginning. So how to approach? Then at following companies, it was much easier, because when you do it once, then whatever you do is at some level repeatable. But that's how we approach first time, and that's what I'm trying to sell you as a concept, or to encourage you to try it on your own. Why? Because like just few of you know what IoT is, so we should start from the beginning. Now, the idea is always to make step by step. So following common methodology, and it's adaptable for any software company, not just Internet of Things. Facilitating external process, and by facilitating external process, I don't mean Scrum Master, because that's what I've heard quite recently, that facilitating external processes is the definition of Scrum Master responsibility. That's not my idea. I mean, Scrum Master is not the solution to solve all the company's problems. Actually, just who of you works in Scrum? Who of you do Scrum? Okay. So that's why it's not about Scrum Master. Then automation tool freedom, because we start, and there was nice talk by Luca about switching tools for platforms. So not keeping like one because I know how to use it, because I like it, but I adapt tool to my needs. Yeah. So I'm not very connected, like emotionally connected with just single device, a single tool. Architecture, because we start with architecture. I never start with just starting typing and coding. Brainstorming session, that's what I recommend you. As a tool to solve the problems, it really works. For me, it always worked, because among like 20, 30 ideas, probably there is at least one having good effect. And team autonomy, which not always is possible, and which is not solved by Scrum Master, but it's just about the concept. Now, let's look at the big picture. It's not that big, because the screen is pretty small, but what we have here. So the biggest challenge for IoT is that whatever is told currently, like modern world, that we move everything into cloud. What's more, we want to have serverless. For IoT, it doesn't apply. Now, why it doesn't apply? Exactly, because we have physical devices. So we need to have them locally. If we have Bluetooth connection or an NFC connection, it must be quite close to mobile device. So we cannot even use any device farm, external device farm. We need to have it in place. I mean, solution to grab that hardware and send to Amazon and ask them to connect is probably not the best solution. So we need to store it locally, at least some parts. So that would be firmware. So so firmware in general, what we create. That would be REST machine. Now, why REST? Because that can be way to download firmware, but how we need to flash the device, we need to connect it by wire or wireless, but close to the device. And we need to have that device stored locally. And of course, that part, we have testing, and if we have testing, we need to have those physical devices at our office or at our laboratory. So probably you see the difference, the major difference. We just cannot move everything to cloud. So whatever is told around the world, this area and automotive area probably as well doesn't really apply. So we talk about something new. We talk about very fresh industry, about something that is high technology and autonomous. But as a contrast, we cannot use cloud fully because we have physical devices. So that's worth to remember, that in that area it just doesn't apply. and cloud is not always the solution. Now, what can be the workflow? Well, workflow is quite intuitive if you think about it, because at first we have something, it's called core build. What is core build? Or core firmware? It's how you control any device. So it's like actually creating API for anything. Yeah. So you have prototyping board, so just the simple board, and you want to control inputs and outputs. You want to control motors. You want to control servo, and so on. So that's common. Then you have firmware specific. So for bulb, it will be different than for locker. It will be different for camera, for pets. But we can use the same base. We can use the same core. Then we need to flash, and at the same time, but it can be in parallel, we have mobile apps or web. But what I see, and that's current trend, mobile first. And very often, mobile first means mobile only. That's current trend. Previously, like 3, 4, 5 years ago, there was always like web and mobile. Now it's mostly mobile. I can give you another example. I had IoT for my cat. Like my cat is better equipped than my wife. So it's like GPS tracker. There is like GPS, there is Bluetooth, there is Wi-Fi. That's cool. So there is mobile application. It's like 5 years old device, and there is web. And recently they decided to skip it. So web is not anymore maintained. Why? Because it's like 10% of customers using it, and that's common trend. So mobile only. Then we have tests, some integration tests, having those real devices, and then we have like whatever, like any data parser, results, and of course, reporting, alerting, but that's the last part of our infrastructure. And probably the most, not the most important in that case. So, automate or automate not? If we talk about fast delivery, no automation means a huge delay, a huge, I forgot the English name. Like you have, okay, bottleneck. Yeah. So your throughput is just slow. Yeah. But exactly that's what I'm talking about. You have bottleneck. You have many endpoints on the road of delivery, and if you stuck at one, there, and that's quite scary. Your competitors will be first. That's, I think, the most scary in that business. Now, what can be the request for that environment? Where at first I always put dirty chip. Why? Because like you can use manipulators and robots, for example, to click your button, but those robots are very expensive, and they apply mostly to industry, like manufacturing industry. That's what I've seen in China. I mean, I spent few months in China working on a production line and building like test environment there. That's what I really call testing on a production, like assembly line, and then you have real production. So for me now, testing on production means something slightly different, but yeah, dirty chip is very important here. Then simplicity, because you have many nodes, you need to somehow connect them. Modularity, separate firmware, separate device, and actually the more devices you have, the bigger infrastructure will be. And you have you have every to every connection. So you can connect bulb with switch, you can connect with blinds, if it's lightning, if you take care about lightning. You can connect a light sensor. So actually you can add another node, just one by one. And if you think about smart home, you want to have it fully autonomous. Or you can, it's temperature controller. And everything is connected together. Then scalability. Why? Just imagine you have 50,000 devices, and all of them are sending packages. usually when we check that, and for example, presentation for the customer, uh, like 10 devices is fine, but if you have 100 of them, it won't work. It will be just the 2.4, because that's the frequency for Bluetooth, will be fully occupied, and it just doesn't work. And then reliability, which is quite obvious. Now, we can start prototyping. And you see on the picture, the most important is that part. So you see the major difference between software developer, and if software developer had that kind of table, well, that's not very well. If firmware developer have something like that, that's very normal. And probably someone will come and ask, you don't have half of your stuff here. What's wrong with you? Now, module flashing, that's how it looks like. So that part is stored at your laboratory. So you need to have something controlling, and what is good? Raspberry Pi, Arduino, whatever you think about as a platform, can be connected as a node to CI tool. So it can be like node in Jenkins, because Jenkins is free, right? So that's their cheap requirement. And that's how it looks like. So just imagine moving it to cloud, not very applicable. One note here, because it's like anyone entering at some point IoT industry is doing the same mistake. When you connect it, it's very often 230 volts or 220 here, as I know. So when you connect it and you don't care about isolation, then there's a huge chance that it will explode. And that's my experience, a lot of smoke and a lot of bad smell when you work for the first time. And it's quite expensive because prototyping boards, for example, they cost like 400 pounds or dollars. Now, switching control, that's stupid solution. That's what I see now from the perspective. But the good thing, you can build it on your own. So to control switches, you just need another platform, like another node, Jenkins node, and then you can control it. Now, since we have AliExpress, you can buy just single module for $2, doing the same stuff. So you have just relays, and they are just switching states. So thanks God we have AliExpress. That's especially for IoT. If we talk about, yeah, it's Chinese, but it works much better. Surely much better than that stuff, which is like a lot of wires, and it's dirty. Yeah. And then you can make it like more explicit. So starting with GPIO control 01. Then you can set as dimming. So probably you know how does it work. If you push the button and you hold it, you can change the brightness of light. And as a last step, and that's very applicable for IoT, you have special combinations. It's like secret code doing something. So if you click like 3 times left button and 2 times right button, you will make a factory reset, and then you can start again. So that's that kind of stuff. Usually it's nowhere, and that's why no documentation is not very bad. And then searching into code, that's quite painful. But it's a different story. Now, vision system. That was very challenging for us building that infrastructure. So you see the concept is pretty simple. We have state, then we have matrix, then we change the state, and we have another matrix. We want to check if that works. Does it work? Who knows? Exactly. Because we don't know what is our requirement. Maybe we set up environment only for those devices to check. That's a tricky question. That's worth to remember. That it depends on us, and that's major thing in IoT. So that's us, that's human, setting up infrastructure and logic, or your grandma. Yeah, that's preparing environment for a node, And that's dirty cheap. That's literally dirty cheap. Why? Because again, if you want to use already done solution, it costs a lot, because all those solutions are applicable for big factories. And if you talk about big factories, then 50,000 K is not a big deal. Like it's just like nothing. If we talk about startup, then 50K is like maybe 2 months of salaries for the employees. It's quite a lot. The same with manipulator and so on. So that's why you need to be quite creative in terms of building this infrastructure. So that's just the story how it was. That's like, I call it tent, then some material, and that's our image. And hooray, it's success. One point here, so who of you ever work with vision systems? It's challenging, right? Very challenging. Now it's much easier since we have Python, since we have a lot of libraries, we have OpenCV, which is it still free? Yeah, that's great. So we can do a lot. When we started, it was not that easy, so that's expectations, that's reality. And it's good to remember to track everything. So if you put too much logs to your code, to your infrastructure, that's not too much. Why? Because you can easily identify what's wrong. And there can be everything wrong, even connection, yeah? Like you have USB connection, and it can be not stable. Or the speed of data transmission via USB. That can be the problem. So it's never too much logs in that terms, in that context. We had that problem that just to be sure, after every run, we rebooted USB. So just to turn off power and turn on to have fresh state. What was the problem? That every time camera was back to the default settings. So that's expectations, and that's what we get every time. That's quite problematic, as you see, based on the values. It's just one of the examples. And that's why I recommend, if you will have a chance to work with that, there is nothing like too much logs. There is always worth to aggregate too much data than too little data, because you have a lot of cases you just cannot predict. And that's what I have every day, almost every day. So that was our IoT brainstorming session. So what scenarios, what the customer can really do? Yes, the customers are quite unpredictable for some reason. I give you one example. Making update, wireless update. So it's written in a structure. If it's blinking orange, don't touch it, because it's updating. And you can imagine what customers are usually doing. It's blinking, so turn it off and on again. And it's bricked. So that's why it's so funny to make that kind of brainstorming, what the user can really do. Probably your grandma is a good person to ask that question. Or anyone, and that's why alpha, beta testing is very good approach for that, because you can have it on a daily basis, and you know what you can do. And that's the cheapest way, actually, to have alpha and beta testing in that terms. Especially if you can provide that device to your family, to whoever you are close to, and can get very direct feedback. By very direct feedback, it means someone telling you it's fucked. That's very direct. Now, that's architecture divided into components. So everything you have seen before, and it's modularity. That's exactly modularity concept. Now, what about the creation then? Well, that's the output of this session. Now, it's of course it's Python. In Python, it's quite easy to write code. So if you have like people not very technically experienced, they still can do it. They still can automate. That's perfect, yeah. Because like assumption is that anyone joining the company, IoT company, usually has either no experience with IoT or very small experience because you have just a few companies doing that. So it should be written in a way you can easily decode. So if you write that, or this, you understand more or less what's going on quite easily. Yeah, that's scenario. That's like middle layer of abstraction. Below you have the whole control, like inputs, outputs, and so on. But on that level, you can quite easily understand. Yeah, is it understandable for you? More or less? Probably if you know business logic, then it will be much better to understand on a higher level. Yeah, if you have documentation, which usually doesn't exist, or if you have good guys who can explain how it should work. But then we have something like that, yeah? If it's more tricky, what the customer can do, so disable in the middle of updating, then, and that's why I always argue with people why behavior-driven development can be useful. You know behavior-driven development? Okay, and test-driven development? Yeah, so test first and then developing. So behavior-driven development is extension of test-driven development. It's like given when then concept. So given is assumption or entry criteria when something happens, which means action or logic behind. Then it's our assertion, it's expected output. Why it's helpful? Because when you translate it into that level, it's much easier to understand. And it's kind of documentation at the same time, right? So you have living documentation. And people usually argue that, but it's bullshit, you need to maintain it, and your business will never use it. But if you do it in a considerable way, so if you think about it, that can be very useful. So if you have no documentation, so that way, that level of documentation is much easier. If you have implementation that is not very understandable, like the scenario before, that level is much easier to understand. And finally, if you have many variables on a way, like you have many channels on the switch, you have like 100 bulbs, then this way can be useful as well. And that is probably quite understandable what's going on in our scenario. And that's a real scenario for the customer. And that's the scenario we started with, as you can see. So the scenario telling us turn on using mobile phone and turn off using switch. And that's the whole environment, the whole infrastructure, and everything except for, of course, this part is stored locally. Major difference between IoT and web mobile software only. Yeah, that's just visualization of Jenkins because of colors. We had a product owner preferring something like that instead of pure Jenkins. Now it's Blue Ocean, which is much better. You know, have you had a chance to use Blue Ocean? It's like the Jenkins addition, like graphical way of building pipelines. I don't like it, so that's why we did it. And we have automation. We can deliver it fast, even if we have only core scenarios, like 20 of them. And that's what I always prefer to do, to have 20 scenarios, but core scenarios from business perspective, covering business pillars, covering the biggest technology risk, instead of having thousands of them. Yeah. Who of you, if you know, have more than 1,000 test scenarios at your company? Okay. Hard to maintain. Yeah. So recently I followed the methodology is very controversial, so that's why I like to talk about it, that we should decrease number of tests. Why? Because it's easier to maintain, it's easier to think about core scenarios. We are focused on the risk. And if you calculate costs of maintenance, of development, and you calculate the profit usually it's not usable. Yeah, but it's a different topic. It's controversial, so we can talk later. So what are takeaways from that? Think big, but act small. The infrastructure itself, we had a very simple scenario, yeah? 2 bulbs, 1 switch. And the infrastructure is quite big. So act small. And then we have iterate and refine. I think it's again Scrum definition, but it's not about Scrum. It's about having small increments and refining them to check if it works. Because most people just doesn't have experience. So it's about experimenting and checking if it works. Stack Overflow, unfortunately, is not that helpful in that terms. So that's problematic. Team creativity, that's your best source of knowledge, of ideas. This big table with ideas, this brainstorming session, that's very useful. Interoperability. Do you know the term, interoperability? Okay, so work on, like, for example, different platforms, yeah? Because, like, 50% of our customers use Android, 50% use iOS. If we target India, so probably all of them, or 90% of them, use Android version below 6, yeah? Or in our case, currently, it's like 70% of customers using Android version up to 4.4. And usually developing, nobody cares about it. 4 point something, it was ages ago. But that's our target group, and it's like 70%, so we need to take care of that. That's interoperability. Then modularity, which is very similar to the first one. Risk-based testing, that's RBT abbreviation. And the example with updating firmware. So that's the biggest risk in our terms. And that's why we can limit number of scenarios, number of tests, and then we can get bigger profit. Physics is roughless. Physics is the word with B. It's better, applicable. But roughless, yeah, we depend on that. I like one example from our company. So we had a problem, like with everything, developing, testing, using it and showing to the customer. So very often when you touch device, it was rebooting. So you know this electricity feeling when you touch something? That's not very pleasant for the person, but not very pleasant for development, even more. Why? Because when you touch it, device is rebooted fully. And it's just imagine you are developing and your notebook is just rebooted. And that's many times a day. So we tried to fix it, I think weeks, and spend a lot of money exchanging like floor to be electrostatic, to not be very electrostatic, changing everything else to build glass tables. And you know, the problem was humidity in the air. So the cost of fixing our problem was like $20. And during the time we spent, like, as I remember, 10K. So that's working in IoT. Quite challenging and worth to be open to very, not very obvious solutions. And IoT is also hardware. And that's example with touching, like your device. And security, so something I didn't mention till now, even in a single sentence. Why? Because it's like the topic for probably half a day. And security, if you think about private data, so IoT is your private data. If you have camera, that's privacy. If you have stored how many kilograms you weigh, that's private data. You don't want to share it. Or anything else, yeah? If it's medical device and it's about your health, you don't want to share it. So it's very sensitive. And unfortunately, if you have vulnerability in one device, that means like 1K devices have the same vulnerability as well. And that's very good source of and it's very popular for hackers to. Yeah, that's very attractive. Why? Because if you have 1K devices, you can somewhere in the background set up Bitcoin miner, And even if it's not very huge power, then if you scale it to 1K devices and nobody realizes because you don't have direct access to memory, it's like earning money, yep. And you don't know about it. It's just one of the examples. Okay, and that's everything from me. If you have any questions, you can find me here. And that QR code is for feedback. And I think we still have time for questions.